Hey everyone, in this video I'm going to introduce the momentum lab that we'll be doing next class. In this lab we'll have two carts rolling on a track. We'll collide them and verify that momentum is conserved during the collision. The track is there to make sure the carts only move in one dimension, so this is going to be a one-dimensional conservation of motion problem. The carts are going to be of two types, either the silver carts like this, or they will be the green carts. We want you to put more mass in one cart than the other, so they'll be of unequal masses. That just means that when you have your conservation of momentum equation, you're not going to be able to cancel out the masses everywhere because the masses of the different carts will not be equal. The square masses will go in the silver carts, circular masses in the green carts. Pretty simple. We're going to be using Logger Pro, so here's the Logger Pro controller. We have two motion sensors, one either end, and that's so that each motion sensor can detect the velocity of each cart. So I think that I'll now go on to Logger Pro and show you what this collision is going to look like on the computer program. So the collision that I'm going to do is going to be one stationary cart. The lighter cart is going to be stationary. The heavier cart is going to be moving. You can do a variety of different things, but that's going to be the choice I'm going to make. In fact, you can see that the table is not quite level because the carts are now moving and when they're supposed to be stationary, so that's a possible problem in the lab. You need to try to pay attention to that and see if that's going to be an issue in your setup. Okay, so go over to Logger Pro. The two devices should be detected, which they are. So we need to do a little bit of setup here. So momentum is a vector, so we need to take care of directions. So I'm going to pick some direction to be positive. Let's say I pick this direction to be positive. But that means that when the carts are moving this way, this sensor is going to measure them moving in a positive sense. But this sensor is going to be measuring them moving in the negative sense because it's going towards the sensors. The sensors are pointing towards the center of the track. So that means that I want to flip one sensor so that it measures in the opposite direction. That's pretty easy to do. Just go to Experiment, Set up Sensors, Show All Interfaces, and then just pick one. I'm going to pick the second one, and do reverse direction. And so that's going to make one of the two sensors measure the opposite direction, and that will take care of the signs in the momentum equation. Now you still may need to think a little bit about what direction things are going in, but at least you won't have any additional errors put in there by the software. Okay, so what I want to do is I want to have the light mass stationary, the heavy mass moving, and I want to collide them and have them stick together. The Velcro is on the same side, so they'll stick. And let's see if I can get a good run here. Okay, actually, so that wasn't too bad. You can see the second mass is the blue mass, and you can see because of the way that I chose my signs, this direction was negative, that direction was positive, because the velocity being red is negative. So I can click on this little sensor button here. So the red line is the stationary one, blue line is the moving one, blue one is moving, red is stationary, then there's a collision right here where their velocities are changing, and then the velocities become constant again. So you can see that the velocity is not actually constant at this point and beforehand. That's because there is some friction on this track. We cannot get rid of the friction completely. But if you do the collision just right around on either side and try to see the conservation of momentum, you should get pretty good results. So we hope that the results will work out. I'll talk about in the lab how to do the actual analysis, but that's the basic setup and how to run the experiment. Okay, thank you guys. See you in class.